Hi students, in previous class we discussed regarding the radius of an orbit either in hydrogen atom or in any other atoms based on Bohr's atomic model. Now another important concept, that is energy of electron. So now, what is the energy of electron and how to calculate that energy? And after that, the relations where we have to concentrate in view of that objective examinations. So for that, just if you see this diagram, electron is revolving in that circular orbit under the influence of this positively charged nucleus. So definitely, since nucleus is attracting that electron towards its center, so thereby to overcome that force of attractions, no doubt that electron has to exhibit energy. So now, since it is in continuous motion, no doubt it is having kinetic energy. At the same time, if you observe this electron, since it is always attracting by the nucleus, to overcome that it has to do certain work in opposite direction to that force of attraction by the nucleus. So that is what we call as potential energy. So first of all, while analyzing the total energy of the electron, here if you observe the potential energy of that electron, since here it is the radius, means the distance between the nucleus and that electron, and since it is that means the potential energy is acting opposite to that of force of attractions. So here it is nothing but minus E square by R in view of that hydrogen atom. And similarly, if you observe kinetic energy, here kinetic energy of the electron is nothing but E square by 2R. Now see the difference. Potential energy is having negative sign since it is acting in opposite direction, and kinetic energy shouldn't be negative, so that is E square by 2R. Now as per this, if you observe the total energy of the electron, this is total energy, which is nothing but the sum of potential energy and kinetic energy. So now if you substitute those expressions, here total energy of the electron, that is nothing but minus E square by 2R. So this is the total energy of the electron in an orbit of radius R. So this is the fundamental information. Now here, if you observe the relations, generally, as per the three formulas, if you observe total energy, here total energy is nothing but minus kinetic energy. Total energy is nothing but minus kinetic energy. And after that, if you observe potential energy, suppose here potential energy is having negative sign, so potential energy equal to, just see the relation, E square by R is potential energy, E square by 2R is kinetic, means half of potential energy is nothing but kinetic energy. So thereby it is nothing but 2 into kinetic energy. Or we can say that, see, if you observe total energy is having negative sign, and potential energy is also having negative sign. So as per that, potential energy is equal to 2 into total energy of the electron. So like this, you have to remember the relation. Now here, in any orbit, if you observe the ratio between potential energy and kinetic energy of the electron, see this, potential energy equal to 2 into kinetic energy. So that means here it is 2 is to 1. That point you have to remember. So this is regarding the fundamental relations between total energy, potential energy and kinetic energy of the electron. Now here in his model, Bohr he derived one expression to find out the energy of the electron. So for that, if you observe that general expression to calculate the energy, before that once again concentrate on these relations, that is potential energy, kinetic energy and total energy. And now we will go for the expression for energy of the electron. So now here, as per his derivation, here we are getting energy of the electron, En, means energy of the electron in nth level. That is nothing but minus 2 pi square into m into e power 4 by h square into z square by n square. So that is the general expression what we are having. But here, see, all these are constants for electron. Now z and n, they are variable. So if you substituted those constant values in different units, we are going to get the formula in a different way. Suppose in electron volts, it will becomes minus 13.6 into z square by n square electron volt per atom. That means if you know the number of the orbit and atomic number of atom of that element, by using this we can calculate energy of the electron. And similarly, if you want to express in x, here it will becomes minus 2.18 into 10 power minus 11 into z square by n square air per atom. These are all conversions, and similarly we can convert it to joules, means minus 2.18 into 10 power minus 18 into z square by n square joule per atom. That is for single atom we are considering. Whereas if you want to express in kilojoules, here it will becomes minus 1312 into z square by n square kilojoule per mole. That is another expression what we are having. And similarly, sometimes, of course, now we are not using kilocalories, but if you want to express in kilocalories, that will be minus 313.6 into z square by n square kilocalorie per mole. So these are all the different relations to calculate energy of the electron, either in first orbit or in second orbit. So because we are having the term n, and similarly either in hydrogen atom or in any other atom, since we have the term atomic number. So like this, by using these formulas, definitely you can calculate energy of the electron in any orbit. Now, based on this, suppose here as like radius, what we observed, R1, R2, R3. That means, suppose if you want to compare the energy of the electron in first 3 orbits of any atom, not only hydrogen atom, so that means here E1, E2, E3. So like that we have to consider. So for that, the ratio of their energies, E1 is to E2 is to E3. See, z square by n square is common. Suppose if you observe hydrogen atom, first orbit 1 by 1, second orbit 1 by 4, 1 by 9. So now here it is 1 by 1, 1 by 4 and 1 by 9. So as per this, it is nothing but 36 is to 9 is to 4. So the ratio of energy of the electrons in first 3 orbits of hydrogen atom, here Z we are considering as 1, so let it be hydrogen. So that is nothing but 36 is to 9 is to 4. So this is another important point what we have to remember. And another one, since energy is proportional to z square by n square, means here En is proportional to z square by n square. Since energy of the electron, that is negative, as per this, E1 by E2, that is equal to z1 square by n1 square into n2 square by z2 square. This is another relation what we have to remember to find out or to compare the energies of the electrons in different orbits of same atom or in different atoms. For that we have to use this relation. And now see, if you know the energy of the electron, automatically we can find out its ionization energy. See, for example, what is the relation between energy of the electron and ionization energy? So for that purpose, what is ionization energy? See, for example, here in hydrogen atom, as per the formula, if electron is in first orbit, its energy is minus 13.6 electron volts. If you want to remove, we have to provide equivalent energy. Means if you utilize 13.6 electron volts, now the total energy of the electron becomes 0. So then it will be removed. So now as per this, if you are, this is what we call as ionization energy. So ionization energy equal to, means in terms of magnitude, both are equal, but it is having positive sign and it is having negative sign. As per that, in general, ionization energy equal to minus energy of the electron. Minus energy of the electron. Suppose the energy of the electron is X, its ionization energy is, that means here negative sign is there. So energy of electron is minus X. So then ionization energy is minus into minus X, which is nothing but plus X. So in that way, we have to find out energy of ionization energy. And one more, if you observe free electron means that is out of atom. Here in case of free electron, its energy will be equal to 0. For free electron, energy will be, this is what we call as free energy, free electron, its energy becomes 0. So this is another point related to that energy. And here one more. Now we will come to hydrogen atom. So as far as hydrogen atom concerned, in case of hydrogen atom, see, with respect to hydrogen, generally in his model he proposed one expression, that means here energy of the electron, that is nothing but minus RH into 1 by n square. Now this is what we call as Rydberg constant, and here RH will be equal to 2.18 into 10 power minus 80 joules. So thereby energy of electron, that is nothing but minus 2.18 into 10 power minus 80 into 1 by n square. Then we can substitute the value of n. Suppose if you observe first orbit of hydrogen atom, first orbit. In case of first orbit, energy of the electron, that will be equal to minus RH. Means here the Rydberg constant in joule is nothing but energy of the electron in first orbit of hydrogen atom. So like this, just by having this idea, already we observed this formula in previous concept. That means the different forms of energies. There we are having this formula. But here directly, if you want to apply for hydrogen atom, it is going to be like this. And after that, suppose if you want to find out the energy difference, means E2 minus E1. So by using this expression, here delta E, that is nothing but E2 minus E1, which will be equal to, here RH is common, into 1 by N1 square minus 1 by N2 square, that is in joules. Suppose if you are using that 2.18 into 10 power minus 80, this is for hydrogen. Suppose if you want to use for any other atom, into Z square. But maximum these relations are as far as the plus one standard concerned, major means 99% the questions are going to related to hydrogen atom. So directly by using this expression, we can find out the energy difference. And here we are having one more formula. That means in electron volts, what about this delta E? So for that, see delta E. Here we are considering two successive orbits. That means E n plus 1 minus E n. Suppose n equal to 1, n plus 1, 2 means E2 minus E1. Suppose n equal to 3, here it will be 4. So in this concept, we have one direct formula. That means 13.6 into 2n plus 1 by n square into n plus 1 whole square in electron volts. So if they are asking regarding the energy difference between any two successive orbits, directly you can use this formula. Of course, these are all we will get by simplifying whatever the general expression that we are having. These are not new, but to find out the answer or to get the answer in easy way, I am trying to give the different relations what you require. So try to remember. So this is regarding energy difference. So anyhow, one of the important formula what we have to remember, that is minus 13.6 into z square by n square in electron volts. That is enough regarding energy. Here, generally, we will expect the questions which are related with energy and radius, or sometimes you have to find out velocity and everything. Since we did complete velocity, we will come to that later. Now, one of the important model here. Suppose here I am going to give two important models. One is, imagine example. Here there is hydrogen atom. Just imagine hydrogen atom. This is hydrogen atom. Now, the electron present in a particular orbit, we don't know regarding the number of the orbit. Okay. So, here it is having a kinetic energy of 3.4 electron volts. So, imagine its kinetic energy, that is 3.4 electron volts. Based on that, they are going to ask the distance from the nucleus, or velocity, or angular momentum. Okay, so anyhow, here the question is, if kinetic energy of the electron is 3.4 electron volts, how far means from the nucleus that electron is going to exist? That means you have to find out the radius. So here the question, if kinetic energy equal to 3.4 electron volts, then what about the distance? Means radius. So how to find out this way? See, kinetic energy equal to 3.4. Already we have a relation. What is total energy? Total energy equal to minus kinetic energy. So according to this, total energy equal to minus 3.4 electron volts. But what is expression for total energy? Minus 13.6 by n square, that is equal to minus 3.4. So as per this, n square equal to 13.6 by 3.4. That means 4. N square equal to 4. Therefore, n equal to 2. That means that electron is present in second orbit of hydrogen atom. So now here we have to go for R2. We have the general expression, that is 0.529 into n square angstroms. So here we have to substitute 529 into 4 angstroms. So like that easily we will get an idea about the distance from the nucleus. So this is one model. Just here we have to convert kinetic energy into total energy. And next, another model. See, here there are two atoms. For example, one is hydrogen and another one is He plus. Suppose if energy of the electron in first orbit of hydrogen atom, let it be E1, that is minus x, either in electron volts or in joules or whatever it may be. And since it is first orbit, n1 equal to 1. What about the energy required? Energy required to remove the electron from He plus. See, here we have to find out first E2, then energy required means ionization energy we have to calculate. So, I will show like this. What is the ionization energy of He plus? He plus means here number of the orbit, let it be N2, that is also 1. So here once again, if you understand this problem, if energy of electron in first orbit of hydrogen atom is minus x, the ionization energy of He plus, here just we have to use the concept of E1 by E2. Let it be, this is E2. First we will calculate E2, then we will convert into ionization energy. So for that, here E1 by E2, that is equal to, what is the formula? That means Z1 square by N1 square into N2 square by Z2 square. So now I am substituting the values. For hydrogen, Z1 equal to 1 and here N1 equal to 1 into N2 square, here 1 by Z2 square, 2 square means 4. So finally, what is E1? E1 is minus x. So minus x by E2 equal to 1 by 4. So therefore, as per this, therefore E2 equal to minus 4x. This is E2. So therefore, ionization energy that equal to minus of energy of the electron means plus 4x. That means if you want to remove that electron from He plus, here we require energy of 4x. If energy of the electron in hydrogen atom is minus x. So this is another model. So that is enough regarding the energy or whatever the points that you require in view of that energy of the electron. And now after that we have three simple concepts. That is nothing but velocity. Directly I am giving the formula here. So now if you observe velocity of the electron, here velocity of the electron, let it be Vn, means in nth orbit the electron is revolving. So what about its velocity? So for that direct formula on simplification, 2.18 into 10 power 8 into Z by m centimeter per second. So that is the formula what we have to use to calculate the velocity of the electron directly. And here also V1 by V2 equal to Z1 by N1 into N2 by Z2. That is the relation. And after that, in hydrogen atom, in view of hydrogen atom, see V1 is to V2 is to V3, means the ratio of velocity of the electron in first three orbits of hydrogen atom. Since here we are having Z by n. Z by n means here first orbit 1 by 1, that is 1 by 2 and 1 by 3. So which is nothing but 6 is to 3 is to 2. So that is the ratio of velocity of the electron in first three orbits of hydrogen atom. And that is enough regarding the velocity. And after that, see, there are two concepts, that is time period and RPS, number of rotations per second. So first we will go for time period. So what is time period? If you observe this time period, here it is denoted by T. So what is time period? See this, this is the circular orbit. And in this electron is revolving. So what is time period? It is the time required to complete one rotation. Means If electron is starting from this, again it has to come to this point. That is one rotation. For that, how much of time it requires? For that, here, generally, as per that, the distance covered is circumference 2 pi r and velocity is Vm. So, based on this, time period T equal to circumference 2 pi r n by velocity of the electron in nth orbit. So, this is the expression what we have to use. But based on this, if you simplify all the values, it will becomes, means finally, time period T equal to 1.524 into 10 power minus 16 into n cube by z square into n cube by z square seconds. So that is the direct formula to find out time period. Means for one complete revolution in a particular orbit, where n is number of the orbit, z is atomic number. So that is the formula to find out the time period. As per this number of rotations per second, means RPS. It is nothing but reciprocal of time period. Reciprocal of time period. So then velocity by 2 pi r. V by 2 pi r. That is the general expression for RPC. Now if you simplify this, here it will becomes, that means 6 point. Already we know that time period. So here it will becomes 6.58 into, that means 10 power minus 16 will becomes, and around, actually it is 0.658, and after that we get 10 power 15 into z square by n cube. So in 1 second, electron is going to make 6.58 into 10 power 15 into z square by n cube rotations. So this is also you have to keep in your mind in view of especially mains. But for NEET also, just remember, try to remember the formulas. So this is regarding the most important common points in Bohr's atomic model. So by having all these, definitely I am sure any question related to that Bohr's model, you will be in a position to answer. So next we will continue another important concept in this topic. Okay, thank you.